Okay, let's look at a couple more examples talking about global extrema. All right, if I talk about the function negative x squared plus 4x minus 5, okay? Notice how we just say find all global extrema. There is no interval. There is no closed interval, so we're going to talk about it over its domain. Okay, so sometimes we're looking for global extrema over the domain, which is oftentimes all real numbers. Okay, so first of all, we already know the answer to this question because we know that that is a parabola that opens down. Okay, we know it's a parabola that opens down. So I know it has a global maximum and no global minimum. Where does that global maximum occur? At a critical point or a local maximum. All right, so how would we find that if we didn't know that? Okay, we still find our critical points, which means we need the first derivative. So first derivative is negative 2x plus 4. We set it equal to 0 to find our critical point. So we get x equals 2. So we have a critical point at 2. All right. Here's where we go back to our original 4 statements about global max and min. Okay. I know that this is a local max. Okay. This is a continuous function. Okay, this is the only local maximum, therefore I know that it is the global maximum. Okay, now if I switch it and I say, okay, what are the global extrema on the interval negative 3 to 7? Okay, so let's think about that for a second. I'm restricting this parabola to only part of it, or sorry, from 3 to 7, my bad. Okay, so how would we do that? Well, we've got our critical point, so we need to check. Is our critical point in this interval? All right, so that means that that local maximum will not be a global extrema because it's not in the interval. So that means my global max and min must occur at the endpoints on the interval because there are no critical points in the interval. Okay. I know it will have one because it's a continuous function on a closed interval. So all I have to do is test 3 into the function and test 7 into the function, which I'm guessing we already have an idea of what's going to happen, but because we know we've got this, right? So if we're looking at from 3 to 7, or something like this, right? We're looking at somewhere to the right on that parabola. So when I put 3 into the function, whoops, I forgot to do this. I end up with, whoops, minus 5. All right, come up with negative 2. When we put 7 in, we come up with negative 26. Now we have to be careful. This is the smallest value. So that means that our global minimum is at 7, negative 26. So that's this point over here. And this is our largest value, closest to 0. This is our global maximum, which is at 3, negative 2, which would be this point here. All right, guess what? One for you to try. Please pause the video and give it a whirl. Okay, if I look at this function, once again, it has no global extrema because it is an odd function, so the range is all real numbers. But if I restrict it to this interval, the interval from negative 1 to 6, it's guaranteed to have a global max and a global min. Okay, so first thing we do is find the critical points. Specifically, we're looking for critical points in the interval, negative 1 to 6. All right, critical points, first derivative. First derivative. Critical points occur at values that make the first derivative equal to 0. So we set it equal to 0 and we solve. Factor out, greatest common factor first, which is a 6. And then I can factor this trinomial. So it'll be x plus 3, x minus 4. So my critical points are x equals negative 3 and x equals negative 4. Okay, are both of these between negative 1 and 6? This one is not. Not in the interval negative 1 to 6. So yes, it's a critical point, but it is not going to be a local max or min. All right? Oops, this should be a positive 4. All right? Is positive 4 in the interval? Is it between negative 1 and 6? Yes, it is. Okay? So this is our only critical point in the interval. Okay? So when we do the test, we test the end points and critical points in the interval negative 1 to 6. Endpoints of the interval and critical points in the interval. So f of negative 1, f of 4, and f of 6. And we're looking for the largest function value and the smallest function value. All right, f of negative 1 should be 74. F of 4 should be negative 201. And f of 6 is negative 101. So, global max. Global min. Basically look for the largest y value. Okay, what is the global max? Largest y value is here. So it occurs at negative 174. And the smallest y value, the most negative, right? Smallest occurs at 4, negative 201. Fini.